cover this a little bit at the end here. Okay, so this is part 2 of today's class, where we're looking at some initialization of arrays. Yeah, okay, this is kind of familiar stuff, right? So you can initialize it this way. An array of ints. Elements all initialized to 0. Yeah, so that's sort of, if you, all right, so if you don't put anything in the curly braces, then it'll just be assumed you want all zeros. Or you could put ABC without the terminating 0. That's a problem, right? Yeah. Pointer problems. Don't dereference the null pointer. Make sure you initialize your pointers. Is there a way to access the end of the array? Access a deallocated object? Yeah, those are all problems, right? Something that's gone out of scope, right? So let's just sort of skip along to the palindrome example. Enough technicalities. Here's a little puzzle. Palindrome. It's a word that is spelled the same from both ends. Madam, I'm Adam. A man, a plan. Wait, how does that go? Yeah, a man, a plan, a canal. Panama. Does that work? So we can maybe test it this way, huh? Do we have which one do I have up here? The Strustrup. That's we got a paint there. So oh, not there. So man. Plan. So where's the middle? Well, you should see Panama coming up here, right? This is Panama backwards, right? Oh dear. Yeah. See Panama backwards? This is terrible writing. A canal? A man, a plan, a man. Oh, I forgot the a plan. I think this is the middle, right? And then you go backwards. Canal. Panama. So yeah, sometimes you have a middle letter and sometimes you don't, right? So if you have an odd number of letters, like in this case, then there'll be an odd man out in the middle. So they say, first we try a version of the standard library string that with int. So this is 18.7.1 or whatever. So let's grab that and take a look at what he's got for that. So here we go. Exclude this from the project. Save it, whatever. Add existing item 18.7. Oh, there is no 18.7. Do you suppose it's 18.6 then? We've been off by 1 pretty steadily, right? So let's see, is this a palindrome thing here? Yeah, is palindrome. So this is the first one. Takes a string and says, by constant reference, right? And says, okay, I've got the index of the first letter. I've got the length of the string, right? Because this is a string object, so it's a standard library string, right? And the last is then going to be 1 less than the length, or the index of the last, right? So while first is less than last, if the opposite pairs don't match, return false, and then increment first, which is just an integer, right? And decrement last, and keep doing that while first is less than last. As soon as first is bigger than last, that means you've overlapped, right? Or they could be the same, right? So in the case of a man, a plan, etc., that's an odd number, so you get a place where first is equal to last, but that's all right. They don't have to be, it doesn't have to have a pair, right, in the middle. Okay, and so I think that's easy enough to see. Shall we test it? So I'm going to say, here's my output window, and it's just waiting for input, right? A man, a plan, a canal, Panama is a palindrome. Yeah. How about Friday, March 13th? That's not a palindrome. Okay. I guess that's all we need to say about that, really. Okay, so we'll move on to the next one, which we'll exclude this from the project and bring in so this is actually 16 in the source code, or 6, sorry, and here's 6.2. This is the palindrome that takes a C-style string, right? And S is then a pointer, right? The name of an array is a pointer to the first element of the array. So the way this is going to work is we're going to have int first equals 0, int last equals n minus. So we have to pass in the second parameter, right, which is the size of the array. And so the index of the last element will be 1 less than the size. And while first, so otherwise it's the same, right? We're just, yeah. And so, okay, but we've got, so main is going to have a constant int max is 128. I guess that's the maximum size of our string. We're going to create an array of characters, S of size max, and we're going to say while read word. So what does read word do? Well, it takes an iStream, a reference, and a pointer to a character, and a max, right? So our iStream reference is going to be CN. Our pointer to a character, our C-style string, is going to be S. Notice S doesn't have a terminating null character. Is that a problem? No, because we're never going to get there, right? And so read word is going to take the input stream, and read at most max -1 characters. I don't know. I don't know what width is. Should we go to definition for width? Oh yeah, see, it's in somewhere in the iOS library. Stream size, right? Okay. Can we get rid of that? Guess we can go back. Oh, where is it? Oh, here. We were doing read word, and read word is using the IOStream's member function width. Read at most max -1 characters in the next stream operator. Okay, so we're going to extract max characters into a variable which is a pointer to a string of type, type pointer to string called buffer. So this is, so is is going to read a white space terminated word. Right, that's the way IS, well, CN in particular, will read until it gets to white space, right? And then return IS. So this is a way of getting the word, right? So it's not that easy to input a C-style string. And so that's why this function looks fairly complicated. It's a lot easier to input a stud string, right? Okay, and then we're going to say is, and if it's not a palindrome, then we write the word not. And then palindrome. I think the function itself works very much the same as the previous one. The hard thing is reading in the C-style string. So we check that this works fine. Do we have another palindrome? Who knows a good palindrome we can use here? Well, there's race car. Yeah, that's a palindrome. Madam, I'm Adam. Oh yeah, there's another palindrome. I think you can get fairly large ones, but let's just move on, shall we? Because time is of the essence. All right. So, all right, I guess I'll close. Well, should we try something that's not a palindrome? Not a palindrome. Yeah. Okay. And put that fish back. Get the next fish. 18.6.3-1, and there's a -2, and that's going to wind it up for chapter 18, except for the drill and the exercises. So, so here, okay, so what's going on here? Here we have a pointer to the first character and a pointer to the last character. And we're going to say, use pointer arithmetic, right? And say, while the address of the first one is less than the address of the last one, yes, I guess the addresses are increasing, right? And so we're going to dereference the first address, and if that's not the same as what we get when we dereference the last address, return false. Otherwise, move forward. That's pointer arithmetic. We increment the pointer to first and decrement the pointer to last. You might say, well, these are constant pointers to constant characters. Well, it's not the pointer that's constant, it's the character that's constant, right? So we're not changing the characters, but we are changing the pointers, right? That's an important concept, I guess. And then we have this read word, which is kind of the same as the other read word. Yeah, so in fact, it's exactly the same, right? So we read the word in, and then we say cout is if this. Okay, so notice we're passing the address of the first element, and since S is an array of characters, I don't think we need the address of S of 0. We can just have S. Well, let's run this, see that it works. Let me see if I can find a good palindrome for us to use. Well, let's go together here. I have to find the and yeah. How about Martin Gardner, Dr. Matrix palindrome? That might be a good source. I haven't checked the magical numbers of Dr. Matrix. The incredible Dr. Matrix. Penrose tiles, okay, so the numerology, so I don't see any palindromes in here. Let's see. If I go to this one. Hello, link. Oh, it's a very long article. I see it's the whole book. So if I search through the book for palindrome, palindrome. We're going to get another one. Clever Russian palindrome. The moon has disappeared. It's a Russian palindrome. Aluna Kanula. So 969, 696. Oh, come on, give me a good. Oh, so these are number palindromes. Entire name was a palindrome. Oh, and then we're back to Luna Kalnuna. All right, we got to have a better source of. Oh, so we can buy the damn thing. Let's get rid of Dr. Matrix, maybe. Oh, and there's an E at the end of palindrome, huh? Do I need to put that in? Games, perfect palindromes, all of these. So here's a WordPress site with, okay. Apropos of your discussions on palindromes, oh, I want a palindrome. Wordplay head scratchers? Sinuousness and footstool are nearly palindromes. What do these sentences have in common? Okay, well, all right, well, sorry, this was a failed attempt. There's some good ones out there, like really long ones. Maybe if I just search for long palindrome. Surprisingly funny palindromes. Okay, so here's a few. Are we not pure? So here's the problem with this one is it's got punctuation, right? And so, oh, and it's got space separated stuff. So what do we see here? Yeah, race car. Right. So none of these are all not palindromes, right? But if you put them all together, are we not pure? No, sir. Panama's Moody Noriega brags. It is garbage. Irony dooms a man a prisoner up to near. So that's the input, right? R is not. So it's white separated, right? White space separated. So how can we fix that? Right. We'd like our code to skip over white space, right? So read word, is that, can we do it there? So here it's using this, right? So I think if we, so this is getting the whole white space. So let's just do a little loop here, right? Do we have a null space character at the end of this thing? So so while so I'm going to say is.get character, right? I guess I better have a character to get. So it's going to return is, huh? This is a reference to a stream. White space terminated word. Well, I'm spending too much time on this, so you get the idea. I think that's going to be it for the palindromes. But yeah, so you run into these problems with using stream operators, as we've seen, right? and it's really nothing new, but you know, one way is to use this get characters. So while that you know, I think there's a function called isSpace. Where is isSpace defined? Do we have a? Yeah, we got some libraries here. Is space like that? Oh yeah, it's is space without an underscore. So while not is space, oh, and is doesn't have necessarily a get function. Okay, what does it say here? No suitable conversion from to int exists. Huh. All right. Yeah, like I say, let's just leave this. Let's get on to the drill. So where are we? Yeah, it's been 4 o'clock. Drill. Define a global int array ga of 10. All right, well, let's just do it, right? So I'm going to get rid of this. I'm going to save it, I guess, because I'm tempted to make some changes, but okay, let's see. Exclude from project, save, fine. So add new item, and this is going to be PPP 18-drill 01. I don't know. Maybe there are 2 of them. I'm not sure. And this is me doing PPP 18 drill. And let's get a statement of the problem, shall we? So problem number 1, I'm not going to go to the text. I'll just copy and paste it over here. Define a global int array ga of 10 ints initialized to blah, blah, blah. Okay, I think I can do that like this. See, I always forget, and it's different in Java, and I just don't use arrays often enough. Ga, like that. Is that the way you do it? 10? I think that's how you do it. And we're going to want to initialize this to 1, 2, 4, 8, 16, 32. This seems familiar. Haven't we done this already? 128, 256 is 8, 512, is that, I think that's 10, okay. Alright, yeah. So now this has got to be a constant, right? So for instance, if I were to have a variable called int ga size or something like that, right? And set it equal to 10, I couldn't put that here, right? Because that's not a constant. Is it going to complain? Yeah. And it's got expression must have a constant value. So, but I can modify this to be a constant, right? And then ga size is okay. All right. Part 2, define a function f taking an int array argument and an argument indicating the number of elements in the array. Seems like we should be getting onto templates, doesn't it? All right. So it doesn't say what to return, so I'm just going to say int size. Okay, consider it done. Um, and do we have to? We don't even have to give this a name, right? Well, I suppose, yeah, if we're going to define it, then we have to give it a name, right? So array of integers. And next, in F, we're going to do all these things. All right. And what are these things? Well, define a local array LA of 10. Okay. So int local array of, oh, you can say Gauss size again, right? It's the same number, 10. Copy the values from Ga into La, right? And so, you know, if you're accustomed to vectors, you're thinking, well, La equals Ga. Well, for one thing, well, Ga is a global array, right? So it's in scope here. However, you cannot use the assignment operator. What does it say? Expression must be a modifiable L value. And La is the name of the array, which is a pointer to an int, right? So is Ga, right? So these are both pointers to ints, but this just isn't allowed, right? So you've got to go through you know, the process of using a for loop, right? So we'll say for int I equals 0, I less than Gauss size, increment I, and set L of I equal to G of I. So much easier with vectors, right? Print out the elements of La. Okay, can I just copy this? Oh, we're going to need some libraries here. All right, and I guess no. Okay. And out, followed by a space, I guess. All right, what else do they want us to do here? Define a pointer p to int to initialize it to the array allocated on the free store with the same number of elements as the argument array. Okay. So that's going to be int pointer p equals new, right? I think they say int of what is it, 10? With the same number of elements as the argument array, which is 10, right? So we can just go like Gauss size again. All right. So this allocates memory on the heap for this many integers and assigns the address of the first of those to P. Copy the define. Copy the values from the argument array into the free store array. All right. Darn it. This is so at this stage, so we have our little for loop, but so into the free store array. So I'm going to say you know, the easiest, the most sensible way is just to say P of I equals AI of I. Print out the elements of the free store array. Okay. I think we can copy that little bit there. And the free store array is P, right? Oh, I guess I want the space separated. It's all kind of tedious, huh? Don't skip the drill. That's our mantra. And so here we are, foolishly following our mantra. All right. Deallocate the free store array. Okay. So that's going to be delete with I think you put the thing there, right, in P. All right. Next. And this is the last bit of this thing, thank God. Call f with ga as its argument. Define an array with 10 elements and initialize it. Okay, so in main, huh? F of ga 10, or ga size, I think that's a global variable. And so call a guy with f, okay. Define an array with AA with 10 elements and initialize it with the first 10 factorial values. Okay. I think was it just A? Use the same global constant here. And the 1, 1, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. Oh my goodness. This is the last one, huh? So 3, 6, 2, 8, 8, 0. I think that's it. And what do they want us to do with this? Mercifully, the last thing. Call f with AA as its argument. Oh, AA, huh? Alright, we'll run this puppy, see what happens. Well, unsurprisingly, it compiles and runs without any errors because it was pretty simple. What are we seeing? We're seeing the printout of the first array, the copy of the first array, copied it again into a heap allocated array, and then called the function with oh, sorry, yeah, no, how come we're only seeing this once? So we deleted P, so that memory is freed up, and we allocated it again, and then we're copying it over, and then we should be printing. We should see it again, right? Because we printed out. Oh, I see. This is the same local array. Yeah, the local array is a copy of the passed in. Oh, the global array, which is this one, right? Yeah. So the global array again. So the only time we see the local array is right here, where God, it's so brain-numbingly dull that I can't wrap my head. Let's go on to the next one, which I don't know if it's going to be any better. Okay, 4:15 already. Let's see, standard library, vector drill. I think what we'll do is get on to the exercises. We didn't skip the drill, we just skipped part of the drill. Yeah, that's what we did. All right, so with that in mind, what's the first exercise? Write a function copies a C-style string into memory. I think we should maybe even get on to templates, shall we? I'll come back and see if there's any worth. I'm sure there's some exercises here worth your consideration, but I think we should need to get started on chapter 19. Vector templates and exceptions. All right. Any? Sir, I demand I am a maid named Iris. Good one. That's somebody posted. That's also a palindrome, although with the punctuation, right? So we'd like to get rid of the punctuation, and that's a worthy function, which I think we've done that or something. But anyway, okay. So let's go to the. Let's close this out. Go to strip, and we see the problem. What is the problem? At the end of chapter 18, our vector reached the point where we can create vectors of double precision floating point elements, copy our vectors using assignment and initialization, rely on vectors to correctly release their memory when they go out of scope, access vector elements using the conventional subscript notation. That was the last thing, right? So that's all good and useful, but to reach the level of sophistication we expect, we need to add 3 more concerns. How do we change the size of a vector after having allocated it, right? How do we catch and report our out-of-range errors? And how do we specify the element type for the vector as an argument? So that's the template part of it, right? For example, how do we define vectors so that this is legal, right? So we got a template, vector of double. We've got a for loop that allows us to, we don't have pushback yet, do we? Yeah, right, so that involves grow the vector to hold more elements, right? Make VC have n elements, so just resize it, right? That's something you can do with vector. Obviously, it is nice and useful to have vectors that allow this, but why is it important from a programming point of view? What makes it interesting to someone collecting useful programming techniques? We are using 2 kinds of flexibility. We have single entity, the vector, for which we can do we can vary 2 things: its size and the type of the elements, right? So the size means we're manipulating the free store to allocate new memory. So it's kind of like the copy stuff, but a little bit different. Those kinds of variability are useful in rather fundamental ways, etc., etc. So not all containers have the same number of elements. Could we live with a vector that held its size fixed by the initial definitions? That is, without pushback, resize, or the equivalent operation? Sure, but that would be unnecessarily a burden on the programmer. The basic trick for living with fixed size containers is to move the elements to a bigger container when the number of elements grows too large. So that's the basic trick. And oh gosh, we need to grab our code, huh? So bear with me a moment while I grab our code. Do I have programming code, chapter 19, and type? So here is all the stuff here. Copy that to the clipboard and then paste it in. Do I have this? No, I don't. Okay. So I just have to jump over to 7B, where we see, yeah. Okay. So now let's get started with this. I'd like to finish chapter 19 anyway, and that would be on Wednesday. So the easiest way to finish it on Wednesday is to start it today. I'd gladly pay you Tuesday for a hamburger. All right. So I'm going to grab in our code. Is that what we're looking at? We're looking at the code, huh? Where's my code window? All right. Excuse me. Remove this from the project and grab existing item. This is chapter 19.1. All right, let's see what we got here. Foo, and without pushback, with pushback. And here's main that calls foo without pushback and with pushback. All right. So foo creates a vector of doubles. So this is using the standard template library, right? And while we can get elements, we push them back on, and then we're going to look to see if cn then resize n. So what are we looking at here? We're going to grow. So how do we get out of this while loop? Well, CND has got to go false, right? And there's two ways that could be. If you try to enter something that's not a double, then Cn will go into a false state, but then, you know, you got to reset Cn. So what's the trick for that again? You've got to say, what, Cn dot clear, is that it? There may be something else you have to do. And then we're going to get a vector of characters, and we're going to say if Cn, we can get an integer n, then the vector of characters we're going to resize with n. Well, that's what foo is going to do. And then we call without pushback. And that's here. Read the elements of a vector in without using pushback. So here we have a pointer to a vector of doubles, which is allocated on the 10 doubles. Wait, this is 10 vectors. I'm sorry. Is that 10 vectors or a vector of 10 doubles? I think that's a vector of 10 doubles allocated on the heap. Yeah. And so P is a pointer to the first. Yeah, I think it's 10 vectors, right? So we're allocating 10 of these things, and we're saying P is a pointer to the first of those, right? Then we're saying n equals 0, and declare D to be a variable type double. Get it from the console. If P, which is a vector of doubles, a pointer to a vector of doubles, if we dereference that and get its size, and if that's equal to 0, then we're going to create another array of doubles. Sorry, another array of well, I don't know. Maybe we should run this and see what happens, and then we can look at the code. And okay, does it compile? Yes, it does. And here's our output. And I want to look at the source code here at the same time. And oh, see, it's waiting for doubles, right? So 2.1, 3.2, 4.3, and then I'm going to enter a character, and it's going to go into crash mode because we cin is not working, right? So how do you clear C again? Gosh, it's the kind of thing, if you forget it, then you have to remember it. So that was our problem with foo, right? Is that foo is the only way to get out of this while loop. Well, there's Control Z. Shall we try it that way? So if I do or Control D, actually I think it's Control Z. So if I go like 1.2, 2.3, 3.4, and then I say Control Z, Control D. Okay, again, then cin goes into a fail state, and we need to recover from that fail state, which simply clear doesn't do that, right? Is it reset? Well, let's look at the so cin dot read binary clear erase ignore. Oh, I think that's it, right? Yeah, you have to like ignore and it takes 2 arguments, right? First one is a character, I believe. And the second one is like a number. I forget why that works. So we could look it up again. So let's see, 1.2, 2.3, 3.4, and then Control D, is it? And again, we're out of there, right? All right, let's look it up. So we'll go to, I'm going to close this and go to browser. And yeah, don't be afraid to look stuff up. It's better when you remember. Neutron monitor. Okay, so let's use this spot. So we're going to say cin recover from fail. Cin.clear puts it in a good state. Well, that's what I thought. So you got an IO error. So we get bools. Okay, so well, that's a question, right? Try using the following combo, right? So, oh, I have the stupid things reversed. I almost remembered it. Okay, so let's go back to our code. And I don't know why he doesn't have that here, right? Okay, so these, because obviously this code isn't going to work without recovering from your error. Okay, so let's try it with that there. Go to the output window, 1.2, 2.3, 3. I'm always entering the same. So then Control D. Oh. Huh. Okay, so what's going on here? So yeah, we're oh, whoops, I don't want that really. I want to say here, we've got this code. We are short of time. So what happens after we recover from our error? Well, we declare VC to be a vector of characters, and we get an int, and it should be waiting. It should be waiting for that int, right? So why is it bailing? Maybe I don't have enough of these guys. Yeah, cn.ignore will discard only one character in the buffer. So that's why we're calling cn.ignore with like a bunch of new line characters, right? Right, because it's, yeah, when you press enter you get that new line character in the buffer. So you ignore that and then you clear the flags, and then you're going to want a cn right here, right? So why isn't it doing this cn? So it still thinks cn is in a fail state. Can we output what cout cn dot what flag fail? Just the fail bit. And then cn.get, that's not going to work because it's in a fail state. Well, let's see what happens here. Oh, yeah, okay, so that's all right. It seems to work. 1.2, 2.3, 3.4, enter garbage. Oh, okay. So now it says 2, which is true. Does that mean the fail bit, so it's got, okay. And then it's pausing, waiting for some, okay, so can we enter like 3 now? So it's going to resize 4, 5, what is it waiting for here? Oh, I know we're out of time. I should let you get on to your next thing. So this should only happen once, and then we're going to resize. Okay, then it's moving on to this second function. Okay, well, we'll take up here next time. We did get started in chapter 19. Sorry, it's a little rough going there. Yeah, I'll let all those fail flags never fail to flummox me. All right, so yeah, stay tuned for an announcement on Wednesday of the midterm part 2. Shall we go back briefly to our agenda? I'm not sure. Did we get through the agenda? Chapter 18. Oh yeah, we exceeded the agenda. Great. Well, then have a pleasant evening, everyone. If there are further questions, you can email me later. Nice to see you all. All right, Logan and Mark, have a a more productive evening, and I'll talk to you next time.